Good morning, everyone, for joining today's webinar. This is a part of today's talk is actually machine learning fairness through social choice. Our speaker today is Dr. Robin Burke, and his title for the talk today is Machine Learning Fairness Through Social Choice. And Dr. Burke is a professor and chair of the Department of Information Science at University of Colorado, Boulder. He conducts research in personalized recommender systems, a field he helped found and develop. His most recent projects explore fairness, accountability, and transparency in recommendation through the integration of objectives from diverse stakeholders. He joined the Department of Information Science in 2019 from the School of Computing at DePaul University. Dr. Burke obtained his PhD in computer science from Northwestern University in 1993. And a BS in computer science from Harvey Mudd College in 1986. Professor Burke is the author of more than 150 peer-reviewed articles in various areas of AI, including recommender systems, machine learning, and information retrieval. His work has received support from the National Science Foundation, the National Endowment for the Humanities, the Fulbright Commission, and the MacArthur Foundation, among others. Dr. Burke, I'm extremely grateful for your time and effort for this talk. The floor is yours, and you can share your screen, and I appreciate you being here with us today.
Well, hello, everybody. Thanks for having me here to give this talk. I trust that the slides are showing up okay?
Yes.
Yep.
Okay, great. All right. Okay, so I think you've heard a little bit about my biography. I did want to say, of course, I'm the one giving the talk, but this work is really joint work that I've conducted with a number of others, including Nick Mattei from Tulane University and Amy Voida from CU Boulder, and students, both PhD students and master's and undergraduate students at University of Colorado. And as usual, the disclaimer is all the great stuff about the work I will attribute to them, and any errors will be my responsibility. Okay, and I'll give also, as you heard, I've been working I'm been working in AI for quite a long time. I got my PhD in 1993, and I've pretty much been working on recommender systems that whole time. It wasn't always called that, and so I've seen a lot of many of the different generations of recommender systems as a technology, and I've seen this field go from something that was sort of an experimental laboratory thing to a multi-billion-dollar worldwide business. So that's been an interesting trajectory. A little bit about the outline of the talk. I'm going to talk about algorithmic fairness and recommender systems, a little bit about how those things go together, fairness-aware recommendation, and talk about kind of our most recent work in trying to get around what I think are the limitations of current approaches by adding this concept of social choice. So I did some thinking about what is the cybersecurity connection, and I think that it's worth pondering this a little bit. Because I think there is a connection. It may not be immediately obvious. So in cybersecurity, we think about protecting systems from attack and the potential disruption of services. And in a way, we can think of the kinds of biases that creep into machine learning systems as kinds of attacks. They're not necessarily the work of specific malicious actors, but it's more that the world contains these biases, the world contains these threats, and because our machine learning systems learn over data that comes from the real world, those threats are inevitably encountered. And so those things can still be harmful. And when we think about fairness in machine learning, we're thinking about trying to mitigate the disruptions caused by those biases present in the world and that show up in the training data. I think one sort of key idea that I've thought a lot about and that we can sort of also share, with the field of cybersecurity is this idea of resilience. You want to have multiple types of defense. You want to dynamically respond to threats in order to keep systems available and keep systems working. And usually in fairness work, we don't really think about that so much. We don't think about combating fairness threats, unfairness in multiple venues. We don't usually think about it as a dynamic problem. That is something I'm trying to incorporate into my work and that I'll talk more about. I also think that transparency is an aspect of resilience, because in an AI system, you don't always have a very complete specification of what it's supposed to do for every given output. It's supposed to learn things and do things that you don't expect. And so then it's very hard to know if the system is doing the right thing. So, so transparency is a really important aspect of making sure that systems are working the way we want to and have the properties that we want. Okay, so let me say a little bit about algorithmic harms, why we should care about fairness. As AI systems have become more prevalent and shown up in more walks of life, we see ways in which their outputs can really impact people's lives, and when their outputs are wrong, impact in a variety of negative ways. So we see lack of opportunity. There's the well-known case of the AI recruiting tool that decided that it was a bad idea to hire women employees because they hadn't hired women employees in the past. And so, an algorithmic system could deny people opportunity. We see a number of well-known cases around false identification of suspects in the criminal justice system. So the imposition of cost or risk on people being accused of things that they didn't do. And we see from Sophia Noble's work, Algorithms of Oppression, she talks about the ways that the effect of algorithms is to produce negative representations of certain classes of individuals. So definitely these harms are there. Now, when we talk about fairness, fairness is a very nebulous and complex concept. Interestingly, we have very intuitive ideas about it, but it's very hard to define. And so I have this very abstract definition of fairness, trying to think about all the different ways that people talk about this idea. So fairness is a normative claim about the distribution of utility. So it's a normative claim in the sense that it's an ethical stance, right? We are saying things ought to be this way in order for them to be fair. It's a comparative aspect. So we're actually comparing between individuals, between groups, it's always a comparative thing. What this person has versus what that person has, that may be what causes the system to be fair or unfair. So we're talking about distribution, and we're talking about the outcomes of the system. And we can think about that very broadly. So the outcome might be, I get certain opportunities, or I get, my resume makes it through the job screening system, or there might be other kinds of outcomes of a system. Maybe I have to do more work to use the system than other people do. Many different kinds of notions of utility. Okay, so that's a very vague definition of fairness, but at least it helps us get started. And there has been a considerable amount of work on algorithmic fairness, looking at how individuals and groups might be impacted by algorithmic systems. And we see it's not surprising that biases in the input can produce biases in the output. It's also worth noting, though, that in a lot of these systems, there are self-reinforcing effects. And so if I, for example, decide I'm going to give this person a loan and I'm not going to give that person a loan, I never find out whether person B would have been a good risk, because I don't get to see them repay the loan and be a good borrower. So my interaction with the world actually biases what training I can receive from the world. And so then, if I'm making distinctions between, say, male borrowers and female borrowers, for example, I might just only start getting my training data from the male borrowers, and that reinforces the bias. And it's the case that biases in the input are going to be endemic in our data because our society has unfairness in it. And we can't wait for society to be fair before we start building recommender systems and other machine learning systems. So many examples, can be cited: healthcare, credit scoring, examples from policing and public assistance. You've probably, encountered these kinds of examples recently. I'm going to talk mostly here about distributional fairness, meaning the distribution of benefits from a particular system. And I'm going to be mostly talking about groups. And so, is the system disadvantaging or advantaging a particular class of individuals? That is not the only kind of fairness. As I showed you my definition, it covers a lot of other kinds of things as well. This is the one that a lot of folks in fair machine learning and in recommender systems pay attention to, but it isn't the only thing we might look at. Okay. And when we think about a protected group, we're thinking about some kind of protected attribute, defining a protected class usually, but not always a minority class. Our goal is that decisions that the system makes should be independent of that attribute. And the protected and unprotected cases should be the same if that's the only difference between them. But really getting down to fairness in practical settings turns out to be kind of hard. So you could imagine a theater at a university like CU Boulder that has this blatantly ageist discriminatory rule. It says, if you're a student, you pay $10 to go to a concert. If you're over 65, you pay $10 to go to a concert. And if you're not one of those two things, you pay $20 to go to a concert, right? Now, I am discriminating based on age and student status. So, people who are 50 years old pay more than people who are 70 and pay more than people who are students. But in general, we're kind of fine with rules like this because, we expect that students, have less money. We expect that, senior citizens are often on fixed incomes who want to provide access to concerts for everybody. So this kind of rule is considered fair, even though, we are making a discrimination around a protected characteristic. So what counts as fairness really depends a lot on the context. And here's another example. I'm cutting up the cheesecake. Alice gets a little piece. Bob gets a really big piece. That seems like, well, that's not fair. But let's say Alice is a toddler and is 2 years old, and she can't eat more than that much amount of cheesecake. And so, we're giving her a piece appropriate, to her, to what she can eat and to her diet. And Bob is a 15-year-old and he's on the cross-country team and he, eats lots of calories every day. And so that's a reasonable piece for him. So there might be a context in which we would consider this to be fair. So, and this is just to kind of, make this point about the complexity of defining fairness. It's not really just a question of, look, oh, A must have the same as B. So fairness is not necessarily equality. It's not necessarily static over time. And I would argue it's not really even necessarily a technical property of a system. Fairness is essentially a political claim. We say, this group is entitled to fairness. And we have seen this, in our own country, in our own time, where ideas say around, the ability of same-sex couples to marry, right? So the idea that they would have the equal ability to marry in, 50 years ago, that would have not been considered an issue of fairness. It's like, that's crazy. That should never happen, right? And now, in, all 50 states of the United States, it's legal for same-sex couples to marry. And the Supreme Court argument around that was an argument about fairness. It was an argument that says, oh, if we give people this right, we have to do that to all the people who want to marry, not just people who are defined in a particular way. So so fairness our ideas about fairness can change over time as we come to different ideas about who should be protected and under what circumstances. Okay, so enough about fairness. I'm going to talk a little bit about recommender systems. So recommender systems give us personalized access to information or items, typically involving the ranking of items by inferred preference. And that's a big part of our experience. Now, this next piece, I'm not sure if this is going to work. Maybe it will. So what I would like people to do is to actually use the Zoom chat and to type into the chat the name of a recommender system that you use. Okay, so don't hit enter. Just type in the name of recommender system that you use, and then I'm going to tell people to hit enter, and then we'll see all of them at once. That way you can't cheat by copying what everybody else said. So I'm going to give people a minute to just type the name of a recommender system that you use, and we'll kind of see what people come up with. I'm going to give a little bit of time for that. Okay, people are being very good and not hitting enter. I appreciate that. Okay, so now you can hit enter and let's see what people typed. Am I only seeing stuff from the panelists? I might not be seeing everybody.
I think we have to make it, let's see. There should be.
Oh yeah, okay, I'm getting some more people. Okay, I'm seeing Google. Yeah, it's interesting. The search engines have become more recommender system-like in the past 10 years, but they're more personalized than they used to be. Certainly, Amazon, YouTube, and in fact, almost. You cannot go through a day, using your phone or using the web without encountering a recommender system. All of these, extremely common apps have recommender systems within them. So it's a ubiquitous part of online experience. So media, news, travel, social media, dating, commerce, recommender systems are everywhere. So let's just talk about fairness in recommendation in particular. So personalization means that people who have different interests are going to get different recommendations. So we can't look at a recommendation and say, oh, Professor Burke gets one set of recommendations and Professor Ranganathan gets a different set of recommendations, and that's unfairness. No, actually, if I like one kind of music and he likes a different kind of music, we would expect those recommendations to be different. That's not a fairness problem. So how do we get at this idea of fairness? Well, we definitely have the sense that recommendation outcomes can be unfair. So if we look at, there's this case from 2018 where job ads in Facebook, jobs that were higher paying were recommended to men and jobs that were lower paying were recommended to women. Seems okay. There's a problem there. That probably shouldn't work that way. And the Federal Trade Commission agreed. So we get the sense that recommendation can produce undesirable outcomes. It can reinforce different kinds of biases. And there's quite a bit of work. You may have encountered some of these books before. Kathy O'Neill's Weapons of Math Destruction, Eli Pariser's Filter Bubble book, which has a lot of other work around it. algorithms of oppression and others. So the sense is there that there may be a problem here. So what does fairness mean in recommendation? There are different ways that we can think about it. We can think about, the system makes more mistakes for some users than for others. That's kind of like an error measurement. We can think about how recommendations are distributed. So say the high paying jobs here, the low paying jobs over here. We can think about the utility of recommendations. Are they actually, things that I like or can make use of? But it's also the case, and I think this is important when we think about kind of machine learning settings kind of more generally, is that in a recommender system, we often have to think about both providers and consumers. And by providers, I mean the people who create or stand behind the items that are being recommended, as well as the people who are consuming recommendations. So in consumer fairness, we can think about, okay, who gets recommendations? And we might want to be fair to the consumers, right? So the readers of books, should male readers get better or different recommendations than female readers? And in some areas like, employment and housing, there's federal rules that say, look, you cannot discriminate, on different kinds of people, which kinds of housing they get to see or get to apply for. So we may care about users. We may care about end users receiving recommendations. Is the system fair towards them? And so this is an example from my colleague, Michael Ekstrand, who's at Boise State University. And he found that different recommendation algorithms had different ranking accuracy for male and female users. And he was looking at book recommendation in this case. And not all algorithms had this property. Oh, I'm sorry, this is not book recommendation. This is movie and music recommendation. Not all algorithms had this property, but in most cases, the male users got better recommendations in terms of their error. We might also care about fairness relative to the items being recommended. And can be concerned about, does each item have a fair chance of being recommended? Why do we care about that? Well, we care about that because there are authors, right? And their livelihoods might depend on their books being recommended. And they may be in protected groups that we care about. And so we want to make sure that, our system doesn't have biases relative to the creators that shows up in the recommendations of the items, what could eventually affect their livelihood. And here's another example. This is also from music. So work of Christine Bauer. She was looking at recommendations, automated recommendations of playlists in Spotify, the music streaming app. And she was looking at solo artists only, and she was looking at, sort of these generated playlists and looking really just at the top 10 recommended individuals. And what she found was that if you just looked at popularity, across the artists in the system, the women artists should have been in the second position around, so just based on popularity. But in fact, the recommendation algorithm put them at the bottom of the list. So the rank of the male artist, of the first male artist in the list was like around 1, but the rank of the first female artist was around 8. And so so there are a few more, male artists and female artists, and so pulling randomly would also put them down a little bit farther. But the system was doing even worse than that. So those women artists were being significantly disadvantaged by the recommender system. And we might want to combine these things, right? So it's possible we might have a situation where we're looking at both consumers and providers at the same time. In job recommendation, we might have protected consumers, female job seekers, but we might also have protected providers like minority-owned businesses. Both of those things might matter in any given system. And, kind of one of these, two-sided issues is what's sometimes called the fairness tax. So it's often the case, although not always, as we sometimes find, that the performance of the system goes down if we try to impose an additional constraint, say around fairness, right? So we optimize the system to be super accurate. If we add fairness, we're probably going to make it be a little bit less accurate. But that cost, sort of lowered accuracy, might not be distributed evenly across all users. And so that becomes then unfairness on the consumer side, because not everybody gets the same sort of, has to pay the same tax when the system has additional fairness. And we've had some papers about that. Okay, so what do we do if we're trying to improve fairness? There's kind of a standard methodology. You sort of identify, the group that you care about, kind of measure the harm or the unfairness, and then you have some wrench, where you go into the machine learning system and you use sampling, or the variety of things that you can do to try and reduce that unfairness while preserving the original performance. And so there's a number of different kinds of interventions in recommender systems: resampling the input data, regularization in the algorithm itself, re-ranking of the results, a lot of different kind of research along these lines over the past 5 or 6 years. Now, as we said, it's complex. And so we have a lot of different logics of fairness, and not just like X should be equal to Y, but lots of other ideas about fairness, as we've already seen. So there's complexity even in trying to say, well, what is our outcome? But even if we chose equality of what? Like equality of appearance in recommendation lists, equality of these error metrics that we were talking about, equality of the value of the item being recommended, like a well-paying job, etc. So it gets pretty complicated pretty fast in recommendation. And my student Jess Smith has been working on helping machine learning practitioners try to navigate this pretty complex taxonomy. Don't try to read this, please. Go to the paper, which is at the World Wide Web conference this year. And she lays out there like, okay, what are the different choices you need to make, and how can that help you kind of identify the specific way to measure and try to improve fairness in your system? But this is a complex space. And I should add, this is only half of the decision tree. There's another half that's for provider side fairness. So there's quite a bit of complexity there. Regardless of how you do it, though, basically, there's going to essentially be some kind of knob, and you turn that until you get the combined fairness accuracy trade-off that you want. So now what do we do in an intersectional case? Because this is the realistic case. It's like, I am not going to say, oh, your system can be as unfair as you want, by religion, ethnicity, all these other things, as long as you're fair, to men and women and, diverse genders, right? That's not how that works. It's like, you need to have fairness across multiple subgroups. And so this has been studied on kind of under the heading of rich subgroup fairness, other terms. So we may have to deal with these multiple dimensions. And what do we do then? It's like, well, there really aren't any good solutions to that. So, we can just sort of try to apply the same metric to everybody. We can try to have some fix that works in multiple dimensions, but it's kind of unsatisfying. And so this is the kind of problem that we have been trying to tackle. One of our key partners is kiva.org. So they are a crowdsourced loan recommender system for microlending in the developing world. And so, as you can see from the pictures here, you could be funding a loan that will support, a variety of different kinds of people: agricultural folks, people working in the textile industry, just a variety of different kinds of things that people need a small amount of capital to be able to, enhance their business, to buy seeds, buy another cow, all these kinds of things where if your, ability in a given country, if you don't have a well-developed system for finance, it might be very hard to do that otherwise. And so Kiva, when they came to us, and we've been working with them for about 5 years, they knew that there were biases in their data because, people just have preferences for certain parts of the world or certain kinds of economic sectors, and they didn't want that to impact the broad availability of capital across all the different people who needed it. So for example, if some countries are just more popular than others, doesn't mean that all the money should go there. This idea of global financial inclusion is a core part of their mission. And they didn't want the recommender system to be fighting against their mission. And so, instead of taking the sort of standard approach, which is to say, oh, let's come up, let's think about what a fairness, consideration might be and build a system and see if we can improve fairness. We realized that actually fairness is a complex concept. It can't be something that we come up with and think about and just say, okay, this is what fairness is going to be. So we actually conducted interviews with Kiva employees and used thematic analysis to really look carefully at what people were talking about when they were talking about fairness. No surprise, people thought about it in different ways, used different fairness logics, thought about different stakeholders, and that's kind of what we expected we would find. But it's not something that people acknowledge so often in the machine learning fairness literature. And none of these things are right or wrong in the sense like, well, that's not fairness. It's like, no, those are all valid views on fairness and all are potential fairness concerns. And we got a variety of kind of different views on that. And that article is going to appear this year in the ACM Fairness, Accountability, and Transparency Conference. So, there are some concerns about the impact of the loans, the cost to the borrowers, the equality of opportunity across different sectors, a whole variety of different things that people there care about, and that we want to make sure that the system can actually attend to. Okay, so what do we need? We need to make sure we can deal with multiple fairness concerns. We do not want to restrict in advance the form that those fairness concerns can have. They should be able to have any reasonable form. We want the system to be as transparent as possible so people understand what it is that's going into their recommendations. And we want to take into account system dynamics because different kinds of loans arrive at different times. We don't necessarily want disadvantage to a particular group to accumulate over time, but opportunities to pursue fairness goals are not uniformly distributed. And we can't sort of make all the decisions at once. We have to make the decisions as users arrive and we give recommendations. Okay, so what do we do? Well, this is where the social choice piece comes in. And I see that I'm running a little bit short on time, but hopefully I'll be able to get through all of this. So social choice is a field with a long history. Basically, the idea is that we need to come up with a single societal preference out of multiple preferences that individuals have. And the classic example is voting. We might all have different ideas about who should be our senator, but we have a mechanism by which people go and they vote, and then the result is this is sort of societal preferences. The votes are aggregated in a particular way, and we have a result. So it's a familiar idea. So we could think about this problem of incorporating fairness into recommendation ranking as a kind of aggregation. The system's predictions, what I think, what the system thinks the user's preferences might be, because that's always a estimate or a projection that the system is making. That's one kind of preference relation. But the fairness concerns that the system has, those are other preferences, right? So it would be fair if this item was preferred over that item, given that we've been unfair, in the past. And so the idea would be, well, we can use aggregation to combine these preferences and produce a more fair result. There's another social choice problem, which is the allocation problem. And the idea here is that you have individuals and you have resources, and people, have different preferences over the resources, but they can't necessarily share them. So, grandma dies, somebody's going to inherit her piano. It doesn't make sense to cut it in half. You want to allocate that resource to somebody, one of the people who are named in her will or something like that, right? So that's an allocation problem, and you want to decide who gets what resources. And this shows up in our context because we can think of recommendation opportunities, like a user comes along, needs recommendations at that moment. We can think about those as resources as far as the fairness concerns are interested. So we can allocate a user to a fairness concern and say, okay, you get to promote your items to this user, taking into account the context. And some fairness concerns might be more urgent at the moment. Some users might constitute better opportunities to pursue fairness goals than others. And so that's where this sort of preference relations come in. So we think of these social choice mechanisms as a pretty good fit for the requirements that we have. So preference relations are very generic. So we're not telling you what fairness has to look like in your application. We have multiple actors because that's what social choice is all about. So it's no problem incorporating, a variety of different fairness concerns. We can draw on all of this history of social choice research. And we think there's transparency aspect there because people are used to using social choice mechanisms like voting in their everyday lives. So all that's good. Now, if you know a lot about computational social choice, you'll know, hey, wait a minute, social choice is really hard. And there's a lot of impossibility results and so forth. There's a lot of cases that go quickly into sort of NP complete territory. And all that's true. So I haven't solved those problems, but it's also the case that what we have been using, for these problems, multi-objective optimization, that's also a really hard, unsolvable problem too. And so we think that there are versions of the social choice problem that are more amenable to solutions. And so I'll spend a little bit of time talking about the architecture we have for this. So SCRUF. Social choice for recommendation under fairness. And the basic idea is that, as you kind of have gathered, every fairness concern that's operative in the system has an agent associated with it. And we think about the recommender system as being an agent in that system as well. And we have a two-phase process by which fairness agents are allocated to recommendation opportunities, users coming along and needing recommendations. And then those allocated agents then combine their preferences using a choice mechanism to produce the final output. So the first thing, of course, is you have to figure out what are the fairness concerns. That's kind of like the stuff we've started to do now with Kiva. Ultimately, those ideas will be embodied in concern-specific agents. Then a user comes along, we decide which agents are going to be allocated to that opportunity, and then those get passed on to the next part. And one of the ways that you might decide what agents get allocated is this historical situation. It's like, well, maybe I haven't recommended any loans to the textile area recently, and so if I have identified that as a group that needs to be protected because of the way the recommendations are being produced, I might say, well, I better start allocating that agent so that I can get back into the sort of at the level of fairness that I'm expecting. So the history might tell me which concerns are more urgent at any given moment. And we have these sort of M value measures like the need to allocate an agent, but also we measure the sort of quality of the opportunity. How likely is this user to be interested in the items that agent is going to promote? So multiple aspects of the matching here. And then we have the choice phase. And so those agents that were allocated in the step that we just saw, those agents are here. And so they're, the recommendation outputs from the recommender system are just another set of preferences, and everything goes into the choice mechanism, and a final set of recommendations is produced for the user. And then, of course, all this stuff goes into the history because we have to keep track of how we did and what fairness is like going forward. So we're optimistic about this, even though social choice is hard. We have a limited number of actors. And so we have a small n. Don't worry too much about an infinite number of actors. We think fairness concerns will have well-behaved preference structures. So we don't have to deal with really totally arbitrary preferences. And fairness concerns are part of a single system. They're sort of architected all at the same time. And so we don't really have to worry so much about strategic issues that come up in repeated social choice settings. And so some of those really hard problems we can punt on, and that will be okay in this application. And as I said, repeated social choice helps. It means we can balance fairness over time. There's a lot of different things to explore there, and we've just started to do that. Here's some preliminary results looking at fairness for different allocation mechanisms. I'm almost out of time, but you can ask me questions about that if you like. So, and we do think this could be applied in more general fair machine learning settings. I don't have any results on that, but I think that's an interesting thing to pursue. So, we have these sort of multiple linked social choice problems. We have non-anonymous agents. We have non-strategic setting. There's actually some interesting things for the social choice people. My colleague, Nick Matte, that's his area. So these are the things he really likes to dig into. As for me, I'm really interested in the recommender fairness piece and how can these ideas actually get us farther towards real practical implementable recommendation fairness solutions. Is there benefit in terms of simplicity of implementation, scalability, dealing with these intersectional cases? Do we have a system that's easier to explain, that has the right sort of normative properties around what we want the system to do, and the kind of resilience to, as the world changes and my results change, can the system actually adapt and continue to provide fair results? Okay, so I think I'm going to end it there, and happy to take any questions you might have.
Thank you, Dr. Burke, for a very insightful presentation. Even though we understand this is at a high level, and I think, one of the things that, and while we collect the questions, I think maybe I'll start with a couple of questions that I wanted to ask. You talked about some of those results where, some of your recommendation systems were, recommending or preferring male over female. Is it because of there are more data associated with male than female? I'm not sure how that association was.
Yeah. So how does the bias show up? So and it differs depending on the domain, but one thing that you see in the book domain, for example, is that there are more sales and more reviews. It looks, say, book crossing is a very common data set that people use. There are more male authors than female authors in that data set, and the average rating, for the male authored books is higher. Now, you could argue, I'm not going to make this argument, but you could argue, oh, books written by men are just better, right? And I think if I made that argument, people would be starting to throw tomatoes at me here. It's like, that's probably not true, right? But we know that there are other biases in society that might cause those things to happen and might cause those biases to be present in the data. And so that's something then that we need to address, right? So, the bias is there. I don't want my system to perpetuate that bias, right? So that's one thing. The other thing that you can see is that sometimes you have groups of users who are themselves in a majority. So now we're not talking about necessarily the providers, but the consumers. And what a machine learning system is going to do is it's going to try and find the part of the optimization space where it gets the most accuracy bang for the buck, right? So it's like, if I make these users happy, I'm going to be a lot closer to my optimization objective, right? So if you can have these kinds of majoritarian effects where the preferences of a smaller group can then determine what the rest of the system looks like in terms of its optimization. And what we see in recommender systems is that the system systems very frequently have popularity bias, meaning that things that are popular get recommended even more than their popularity would suggest, because the system is trying to sort of milk the popularity, kind of aspect for all it can, right? Because there's a lot of signal around the popular items, right? There are thousands of people who, hundreds of thousands of people who've rated Titanic, right? And there might be many, many fewer people who've rated more obscure, movies. And so there's just more signal there. And so just the way we train our systems kind of pushes them towards those areas where there's more signal.
Great. Follow-up question. All this fairness theory is from a societal context. And you already mentioned that our society is endemic, more like there's unbiased in the type of examples that we're biased. We are biased in a way to, the pie or the tickets example that you talked about, but how do you see one should, as a machine learning researcher or a data scientist who are listening to this and handling fairness from a cyber physical systems or the interactions between agents? You talked about consequence, contract, and function based. Should we adapt these things in a subsystem domain or systems of systems perspective as we look at those properties to model that? Do you know any work has been done in that area from a systems point of view? I'm just curious to see, because we are talking about everybody wants scalable system, resilient systems. You brought a resilience.
Yep, exactly.
I've been dealing with resilience for critical infrastructures evaluation, but there is not a unified agreeable metric to look at resilience. It's so hard, but it is hard, like you said. This is even a very hard problem for this domain that you're talking about. But I just want to pull up your perspectives on.
Okay, well, I'm not saying, so I'm totally in agreement. It's hard. And, if the problem of kind of unfairness in our society was easy, maybe we would have solved it by now, but these problems are substantial. And, as computer scientists, we're not going to solve all of society's problems. But I think what we can do is we can try to avoid reproducing society's problems in our systems as much as we can. So, and this is kind of where we're coming from, in working with Kiva. It's like trying to understand, how do we do this from a really stakeholder-centered point of view? It's like, I need to ask you, as somebody who is affected by the system or who uses the system, you tell me what it would be like for you to be treated fairly by the system. It's like, that's not something I can come up with sitting at my desk. It's like,
but there is a conflict between the producers and the consumers,
There is, right? And so ultimately, like, you think about Spotify, right? So Spotify cares about the producers. They don't want a music ecosystem that's only dominated by, Drake and Beyonce and Taylor Swift. They want, independent new artists to be able to arise and their music to get heard and so forth. They want to fight some of these efforts. And so they're advocating on part of the providers. On the other hand, personalized recommendations is something that people come to the app for, right? And so there is a difficult balancing act there. But I don't think that's any different from the other kinds of balancing acts that we do in system design all the time, right? And so kind of there's, you have issues between like, okay, I can add this feature, but now my response time goes down. Like, those kinds of trade-offs show up all the time. And so, we can, try to use some of our, our standard techniques for dealing with that. I think the transparency piece is super important. You need to tell me that this is what you're doing. And also, that there's appropriate, consultation with stakeholders to even really understand what that fairness definition should be. How do I know that the system is fair towards a group of folks unless I ask them, what would a fair outcome look like to you?
Great. Nirup, do you see any questions on your end?
Nope.
Okay.
No questions yet. Although I do have one question for Dr. Burke.
Sure.
Could you comment on how recommendation systems can perform in cases where organizations actually give the users the option to opt out of the data collection process?
Okay, now that is a super good question. So I'm really interested in this. So and I'm actually starting to do some work with social media in the Fediverse and the Mastodon kind of messaging microblogging app, right? So people are leaving Twitter. Mastodon is one place that people are going to, and once it gets big enough, people are going to start to need automated feed ranking, just like they had to do that in Twitter for all the same reasons. People getting deluged with too much stuff. But in that setting, we have a sort of very decentralized ethos. We have this idea that, some people may not want to have that kind of mediation of their ranking. So the question is, okay, what do we do when we don't have that much control over the system? And, there are various things. So for example, there are recommendation technologies that don't actually make use of the collaborative input of your social peers. So I can just build a classifier that looks at you, looks at the kinds of content that you read and that you pay attention to, and tries to figure out what that is. And I don't have to look at anybody else's data to do that. I can just look at you and the content of the tweets. Now, I don't get all of the advantages of serendipity that I get when I can look across a whole social collection of people. So I think it's very interesting to think about, okay, could we pull in that social signal, understanding that it's sparse, understanding that it's biased, knowing that we can't rely on it completely, but trying to incorporate that into sort of a content or other kinds of signals that we might get that are not necessarily based on that social information. So I don't have an answer for you because this is an active piece of research, but I think that's very much an important question, because we have been in this situation where we have kind of outsourced kind of important aspects of our information infrastructure to big companies, and their model in social media in particular is you're paying for this product with your attention. And so, we're going to use it as a way to capture your attention, then we can deliver advertising, and that's our model. It's free to you because you're paying us with your attention. If we want to think about public service kinds of analogs of that, it's like, then we have to think differently about how recommender systems work and what their, kind of what people's relationships to them are. And more of these kinds of questions will arise.
Can you go to your last slide where I had research questions,
Yeah.
and just for 1 minute. And I think I really enjoyed your definition of this fairness in the very first beginning. You said normative claim of distribution of utility. And that just sits me in my head. It's a very appropriate.
It was like the most abstract thing that I could come up with.
Yeah, I mean, it has a lot of things. Yeah, you said ethical distribution of utility. I think that's. I'm just trying to understand this. I think, but you
and actually, in that the setting was, I told my graduate students, like, she was like saying fairness can't be defined, and so this was like a challenge to me. It's like, yes, we can define it. If we're abstract enough, we can define it. So eventually, we found a level of abstraction that everybody could agree on.
I think that's you mentioned a couple of things, which I do not understood, in a way. You said fairness, you're looking at it from a single system perspective, and it's not necessarily static. And, I'm just picturizing that, from a systems point of view. And I do a little bit of this agent-oriented modeling too, but I think so could you please elaborate on, how do you substantiate that claim by looking at fairness is actually within a single system? I think I saw that somewhere in your slide. Yeah.
Well, that was really kind of me saying, that's sort of what I'm looking at, right? So I think that there's some very interesting questions around system composition, right? And so you could imagine if I look at each of these pieces in isolation, I think, oh, everything's great, right? But once the systems are composed in some larger thing, then I'm going to see, oh, there's actually unfairness. And actually, we saw this a little bit in our interviews with the folks at Kiva, where they were talking, we are focused on the recommender system because, that's what I do. It's like I look at recommender systems. But the people there were saying, well, like, look, part of the unfairness comes in because of the inputs to that system, because of the way that we interact with our lending partners in the field, because of the way that currency markets handle transfers. It's like there's a lot of complexity in the microfinance domain, especially because it's a global it's a global system, and so far our attitude is like, this problem's hard enough. We're just going to try and work on this. But I do think that an important next stage of this research is to start thinking about, okay, can we think about this whole pipeline of how loans get funded? What are the various places where there are issues around fairness? Some of them may show up in the interface, but some of them may be things that we have to address in other parts of the system. So the single system perspective is really just me saying there's only so much I can do, and I'm gonna focus on this. The dynamic piece, the idea here is that we can't necessarily predict who is going to arrive, how loans are going to flow into the system, how different, so for example, a war breaks out in Ukraine. Suddenly people want to loan to Ukrainian entrepreneurs. It's like, that's good. We want that to happen. But it doesn't mean that people in Kenya and Malaysia don't need loans anymore, right? And so that burst of interest, that's good. It might bring people to Kiva. It might bring more money into the system, et cetera. We don't necessarily want the recommender system to pick up on that and say, oh, everything is about Ukraine now, right? And so the sort of the dynamics of user interest, the recommender system is going to pick up on that because it's driven by popularity, it's driven by people's interests, and we have to be able to adapt to those changes in more or less in real time. Otherwise, we're in a situation where it's like at the end of the week we have to go back, oh, it's like we really screwed up. Now we have to change the dials again, right? So the system has to have that kind of ability to adapt, and we're definitely not there yet. So this is one of the things I'm interested in, is kind of how do we make the system more dynamically adaptive in its ability to apply the different fairness concerns over time.
Great. I think that was a very insightful discussion. Thank you so much. I think that's all we have questions, I believe, and thank you for your time and today. And so we sincerely appreciate the effort that you have put for this webinar, and look forward to further conversation. And,
yeah, great talking to you. Thanks for having me.
Thank you. Yeah.
All right. Bye-bye.